Right then, shall we finally have a go at doing an example? So in this one here, we're going to have a look at an example of constructing a t-standard error confidence interval, which is sometimes also called a norm-based confidence interval, because it comes from that t-distribution, which is based on the normal distribution. So we're going to have a look at an example from the book, and we're also going to have a look at an additional example as well. But first, a question for you. Have a go, read through these, pause the video, and when you come back, we'll go through the answer. Okay, let's have a look at which of these is false. So firstly, A, the size of the t multiplier changes if the sample size changes. So this one is true, and it comes down to that idea we looked at briefly in the previous video of the degrees of freedom. So degrees of freedom is sample size minus 1, and as the degrees of freedom changes, the t-distribution changes. So for small degrees of freedom, it might be like that, but as the degrees of freedom gets bigger, it might get skinnier like that. And what that means is that where 95% of that distribution ends, so for the skinny one, it might end here, and that will be your t multiplier. But for the fat one, it might end all the way out here, and so your t multiplier is larger. So the t multiplier does change as degrees of freedom changes, which is impacted by the sample size. I've exaggerated it in my drawing. It doesn't actually change a huge amount. The t multiplier is usually pretty close to 2. So that's the first one. Let's go on to B. The width of the confidence interval does not change based on the variability in the sample data. So if we remember our formula for the confidence interval, and I'll just show you briefly where you can find the formula sheet. So under modules and lecture notes, right down the bottom of the page is the formula sheet. It looks like this, and this will be provided for you for the mid-semester test and also for the exam. And it's just this top bit here, the confidence interval formula, that we're looking at in this chapter. So the question, or the statement, was asking the width of the confidence interval does not change based on the variability in the sample data. So variability is going to impact, can't write on it, it's going to impact the standard error. So standard error, if you remember, for a sample mean has the formula S over root n. So S is the sample standard deviation, or the variability in the sample data. So the width of the confidence interval does change depending on that. So that was our false one. Moving on to C, the t-distribution is centered at 0, the tails are around 2 and minus 2. So these t values here, like I said, they're almost always around about 2, and they're at that 95% limit of the distribution, so they're out in the tails. So that one is also true. D, the confidence interval for an estimate from a small sample will be wider than an estimate from a large sample. So small samples, lots of uncertainty, lots of sampling error will give us a wider confidence interval. Now, the last one, we can be 95% confident that the true value of a parameter is somewhere in the t-standard error confidence interval. So this is really the key part of what we've done as we've changed from a bootstrap interval to a t-standard error confidence interval. So in a bootstrap interval, we always took the middle 95% of the bootstrap distribution. But that bootstrap distribution is just an estimate for the sampling distribution. And what we found when we looked at how well that method worked, how well bootstrapping worked, it worked pretty well, sort of 96% of the time I think is what we got in our simulation. It's going to be somewhere close to 95%, but it changes a bit depending on the sample size. So for bootstrap confidence intervals, we don't have a level of confidence that we assign to that interval. It's why we use language like, oh, it's a pretty safe bet, or I'm pretty sure that, or it's I'm fairly sure that the parameter is somewhere in this interval. That's why we say that. This is different though with a t-standard error confidence interval. And as we saw in the previous recording, by using the t multiplier and taking into account sample size, and by using standard error as an estimate for the sampling error, we can actually get an interval that pretty much works 95% of the time, regardless of sample size, regardless of how varied the data is, regardless of any other factor. So there are sort of some assumptions in that, but we don't really cover those until chapter 8. But for now, yes, we can be 95% confident the true value of the parameter is somewhere in a t-standard error confidence interval. Before we get into our examples, I just want to talk really quickly about how to study for stats, because your mid-semester test is coming up, and even though it's a different format to before, not that bothers you because you didn't do it before, but it's different. It's going to be more open book. You've got 24 hours in which to submit it. But I think that it's important as well to be prepared. You don't want to have to be spending heaps of time going back and looking things up. So obviously, if you had access to super advanced alien technology, you could just download Stats 100X into your brain. For the rest of us, best resource is using the past tests that are on Canvas. So there's two ways to do this. Past test questions under modules in that module you can see there. And the answers are provided at the end of each test as well. The other way is the test revision app. So the test revision app works the same, but instead of, I'm just going to find it and then I'll show you. Instead of showing like the whole test paper at once, it shows you question by question. Here it is. So you can choose to use the test revision app one of two ways. You can either go into test mode and then you just pick a semester that you want to do, so say the most recent one, and you can just do those questions. The other way, how do I go back? Oh, and when you go in, you like work out the answer and then you click for the answer. Or you can do review mode, and in review mode, you can pick which chapter to focus on. So you might want to do all the chapter 1 questions first. You must unselect that. Right, so I might want to do all the chapter 1 questions first. And that's another way to do it. So, totally up to you. The revision app, or you can just go through the past tests. Where'd you go? Here we go. So there's 5 of them there. You want to do all 5. So before you walk into the test, or before you start taking the test, you want to have completed all 5. You want to do some reading and making some notes. You want to do the past tests. And what will probably happen the first time that you do one is that you won't get a very good mark and you'll probably freak out. That's okay. They're multiple choice and they are a lot more difficult than you might think a multiple choice question is. There's often some quite picky things with the language that we use. So you want to make sure that you've seen as many past questions as possible, because we're not terribly inventive. We're going to be using very similar language to what we've used in previous tests. So once you've done one and you've had a little freak out, go back, go through the questions that you got wrong. This is very important. Try and figure out why you got them wrong. If you can't figure it out, use the resources that are available. Use Piazza, use the online assistance room, book time with me on the You Can Book Me link, and we can have a chat as well. I'm more than happy to help you with your studies. So make use of the resources that are available. Don't get a question where you're like, I don't know why I got that wrong. Oh well, move on. Because what will happen is something similar will come up in the test that you have to do and you still won't know how to do it. So go back, make some notes, figure out what went wrong, do another past test, and hopefully as you go through this process over 5 tests, you'll freak out less and less and less. That is my main advice in how to study for the test, and the same kind of thing for the exam as well. Okay, so in this part, An example, so we're going to calculate a 95% confidence interval for a single mean. We're going to look at interpreting it, and we're going to learn about this thing called margin of error. So here's our context. This is the one that's in your book at the start of Chapter 6, page 5. So what is the average number of hours worked per week by all those Stage 1 STAT students who have a part-time job through the semester? So in that question we can see this part here, that's our population. We're talking about average, so our parameter here is going to be a mean. This method, this Chapter 6 norm-based confidence interval method, doesn't work for medians, so whenever we say average, we're going to be using a mean in this chapter. So we've got our population, our measure, and the variable is the number of hours worked per week. So that description in there is our parameter. So that's our population. We haven't got access to everyone, and in this case we have a sample of 12. So from that sample of 12, we've got an estimate for the mean, 12.5. So that would sit here. And we've got an estimate for the standard deviation as well. You need both of those numbers, the mean and the standard deviation, to be able to do the rest of the bit. Okay. So when we come to doing these questions, we have some steps to follow. So when you do assignment 2 and you're doing a Chapter 6 question, you will be asked to follow the step-by-step guide. So this is the step-by-step guide, 7 steps to producing a confidence interval by hand. So step 1, state the parameter, symbols and words. And I've already shown you this, you're also going to need that formula. We can see up the top there, we're looking at a single mean. So our parameter is mu, a single mean, and our estimate is x bar. Degrees of freedom is n minus 1. So here's our parameter. So in symbols, mu, and in words, the mean number of hours worked per week for our population. Okay, so that's our parameter. Step 2, our estimate. So here we go. So this is just for the sample. And our estimate for the mean, 12.5. Next step, give the formula. So on the formula sheet, it's given with the word estimate. We're replacing the word estimate with x bar. So you can see how it sits there. Next, we need our standard error. So we're going to have to go over to the T procedures tool. So we're choosing our situation, which is a single mean. Our estimate was 12.5. Our standard deviation was 5.73, and our sample size is 12. We've got a confidence level of 95%, and we're going to talk in another video about what happens if we change that. So there we go. There's our standard error and our T multiplier. Okay, and here we've got, where we're stating our T multiplier, we're also stating our degrees of freedom, which is that n minus 1, which we can look up on our formula sheet. Step 6 is to actually do the calculations. So here we go. We're just plugging the numbers into the formula that we worked out back up here. 12.5 is our estimate, our T multiplier, and our standard error. We do this part of the calculation first. So the T multiplier, it's a multiplier, its life dream is to be multiplied, so do the multiplication first. And then once you've got that, what you've calculated here, when you've multiplied those two together, is called the margin of error. So imagine your x bar, your 12.5 sits in the middle, and then you add on 3.64 to get 16.1, and you subtract off 3.64 to get 8.9. And that's your confidence interval. So the margin of error is 3.64. It's like the bit you're adding on and subtracting off. Another way to think about margin of error is if you take the entire width of the confidence interval and you halve it, that will be the margin of error as well. So half the whole width of the confidence interval is the margin of error. Our final step, step 7, is interpreting. So this is the slide we've seen before when we did bootstrapping, but there's a small change. So when we did bootstrapping, we had to have some fuzzy language. Remember, statisticians like to be a bit non-committal. So you don't want to commit and say for sure that the parameter is in that confidence interval, because we're not sure. We don't know 100% sure that it is. But with bootstrapping, we were fairly sure. So we used some language around that. For t-standard error confidence intervals, we use the specified level of confidence. And that's what you put in the t-procedures tool here, the confidence level. So we're at 95%. So we're going to start our sentence with something like, with 95% confidence, we estimate. Okay? Then we talk about the parameter, same as before, and the interval. All right, so let's get to interpreting. So for all those statements,